Imaginary numbers. What are they? Well, first, let's talk about squaring and square rooting. So we know that 3 squared is equal to 9, and we also know that negative 3 squared is also equal to 9. So the square root of 9 is equal to plus or minus 3. But what about the square root of negative 9? What's that equal to? Or in other words, what number, when squared, gives you negative 9? And there is no real number that is the solution to this. There is another group of numbers that aren't real or on the real number line called imaginary numbers. And they're defined as the square root of negative 1 is equal to I, which is the imaginary component. So, if we want to find the square root of negative 9, we could simply split it into the square root of 9 times the square root of negative 1. Square root of 9 is plus or minus 3, square root of negative 1 is I. So the square root of negative 9 is equal to plus or minus 3i. This brings us to the complex plane. So this axis is the real number axis, and it is essentially just the real number line. So any number on here is just a number you're familiar with, any real number. But this perpendicular axis is the imaginary number line. All imaginary values are on this line. And then any combination of real and imaginary, so something that has a real and imaginary component, is called the complex number. And so, for example, 2 plus 3i would be 2 real plus 3 imaginary. Negative 3 plus 3i would be negative 3 and 3i. Or negative 3 minus 3i would be negative 3 minus 3i. So, any complex number with a real and an imaginary part can be graphed on the complex plane. This brings us to number sets, which are all the different categories numbers can be in. Here are the broad sets that numbers can be in. First, natural numbers, integers, rational numbers, real numbers, and complex numbers. So natural numbers are also called counting numbers. So 1, 2, 3, 4, 5, 6, 7, 8 till infinity. The set of all natural numbers can be denoted with this n symbol. Next, integers, which is all positive numbers, so it includes all natural numbers. It also includes 0 and all negative whole numbers. Any positive, negative, or 0 whole number is in the set of all integers, and the set of all integers can be represented with this z symbol. Next, rational numbers. Rational numbers are defined as any integer over another integer. So 0 divided by anything will be 0, and 1 divided by 2 is a rational number. Negative 2 divided by 1, which is the same thing as negative 2, is also a rational number. And this continues. This also includes all integers, but also all fractional values, or rational values, from negative infinity to positive infinity. This can be represented with this q, which stands for quotient. But there is another group that rational numbers don't include. Irrational numbers. And irrational numbers are things like the square root of 2, or pi, or e. These numbers can't be represented with just a rational expression. Instead, they have to have these numbers can't just be represented with a rational expression. And so, they also can't be represented by a finite or infinite periodic decimal. And as we saw, real numbers aren't all the numbers. There's also imaginary numbers. And finally, if a number is both real and imaginary, it isn't a real or imaginary number. Instead, it is a complex number. So 1 plus I, 5 minus 2i, a minus bi. And these don't have to be integers. These can be any real numbers. And this is denoted with this c. And this is denoted with this r symbol. However, these aren't all of the number sets. For example, there are whole numbers. So whole numbers are all of the natural numbers, as well as 0. There's also algebraic and transcendental. Irrational numbers can be split into these two groups, where algebraic irrational numbers are things like this, where they are the square root or cube root, or any real solution to a polynomial with integer coefficients. And then transcendental numbers are things like pi and e. There is no algebraic expression that resolves to be exactly pi or e. Instead, you have to use calculus or some other method to figure out what these numbers evaluate to. And also, numbers can be closed under certain operations. So closed under addition, subtraction, multiplication, division, powers, and other things. So, for example, natural numbers are closed under addition. If you add any two natural numbers together, you will always get another natural number. But they aren't closed under subtraction, because you can subtract 3 minus 4 and get a negative number, which is not a natural number. Integers, on the other hand, are closed under addition. They're also closed under subtraction. They're also closed under multiplication. However, they aren't closed under division, because 1 divided by 2 is not an integer. Rational numbers are closed under addition, subtraction, multiplication, and division, but they aren't closed under powers. For example, the square root of 2. Real numbers are closed under addition, subtraction, multiplication, and division, but they also aren't closed under powers. For example, the square root of -9, as we saw, is not a real number. Finally, the complex numbers. Complex numbers are closed under every single operation, because any number can be represented as a complex number. And if you can think of any fun number sets, please leave them in the comments.